Hi everyone. Today's lesson is going to be about fitting a quadratic equation if we have been given 3 points to work with. So let me just take a look here for a moment. I've set up a GeoGebra where I've got 3 points A, B and C with these coordinates, and my job is to find a quadratic formula which will hit exactly these 3 points. So let's see how we do. There's our 3 points. There's our standard form of the quadratic equation, y equals ax squared plus bx plus c. Now if I substitute from point A a value of 2 for x and a value of 3 for y, so 3, now 2 squared is 4, so that's 4a, plus 2 for x, 2 times that is 2b, plus c. Let's call that equation 1. Now I'll substitute the value of b. The y value of 6 would take the place here. X is 4 this time, so 4 squared would be 16 times a, 4 times b, plus c, and we'll call that equation 2. And then lastly we'll put in point c, so the y value is 6, x value this time is 8. 8 squared is 64 times a, 64 times a, 8 times b, plus c, and we'll call this one equation 3. So we have 3 equations in 3 unknowns, a, b and c. Now if I knew those 3 unknowns, a, b and c, then they would be the things that define my solution to this quadratic model that I'm searching for. So my job then is to solve these 3 equations simultaneously. Now I notice that I've got value c, value c, value c here at the end. What if I go equation 3 subtract equation 2? So 6 take 6 would be 0. 64a take 16a. So 64 take 10 is 54, take another 6 is 48a. Then 8b take 4b is 4b, and c take c disappears, as I was hoping to eliminate. Let's call this one equation 4. Now I think I'm going to go equation 2 subtract equation 1. 6 take 3 is 3. 16a take 4a is 12a. 4b take 2b is 2b, and c take c disappears, and that's equation 5. Now how can I go from this? Well, I notice that I have 48 times a and I have 12 times a, but easier would be 4b and 2b. If I doubled equation 5, this would become 4b. Then I could subtract, couldn't I? So that's what I think I'm going to do. I'm going to go equation 4 subtract 2 times equation 5. 2 lots of that would be 4, subtracting would eliminate b, that's what I'm trying to do. So I have 0 subtract 2 times 3. I have 48a subtract 2 times 12a. I have 4b subtract 2 times 2b. That's what I was trying to do, eliminate b. So that's negative 6. 2 times 12 is 24. 48 take 24 is 24a, and the 4b take the 4b disappears. This allows me to write negative 6 over 24, which is a, and that's negative 1 over 4. So I found the value for a. Now let's substitute back. Would I rather use equation 4 or equation 3? I think I'd rather use equation 3 because the coefficients here are, equation 5, because things are a bit smaller. So I will substitute a into equation 5. Equation 5 read 3 equals 12a, 3 equals 12, and of course a is going to be replaced with the value negative 1 over 4 plus 2 times b. Now 12 times negative 1 over 4 is negative 3. Adding 3 to both sides gives 6 equals 2b, and dividing 3 by 2 I find that b equals 3. So I now have a value for a value for b. If I was to go back to any of the original equations, and I might choose equation 1 because the coefficients are smallest, I will be able to calculate c. So I'll use equation 1. I will substitute a and b into equation number 1. So equation number 1 said, where are you? 3 equaled 4a plus 2b plus c. 3 equaled 4a plus 2 times b plus c. 4 times negative a quarter is negative 1. 2 3 is a 6. 3, that's 5 plus c. By the time I subtract 5, I think I'm going to have that c equals negative 2. So my answers for the coefficients here, c is negative 2, b is 3, a is negative 1/4. What does that mean for my equation? Well, that gives me then that y equals negative 1/4 by x squared. Now b was 3, wasn't it? Yes, and c was negative 2. Plus b is 3 times x, and c is negative 2. There's my formula that I think will do a good job of modelling those points. Let's just bring GeoGebra back for a moment, and let's type that function here. Let's go f of x equals, we had negative 1 over 4 by x squared, then b was positive 3 times x, and c was minus 2. And look at that. Our quadratic equation that we analytically determined through simultaneous equations has exactly hit all 3 of those data points, as it must. 3 points are sufficient to define a parabola. If I was to do an r squared value, and the list of points that I'm going to give GeoGebra are point A, B and C, and the function to compare with is f, then obviously I get an r squared value exactly 1, because this function is a perfect match. It was a bit silly to do the r squared, it's a bit meaningless. 3 data points will always be able to have an exact match with a parabola. So remember, if there's 3 data points, you need 1 less than that. A second degree polynomial could exactly match those 3. Well, I think that's enough for now. Thanks for watching.